They haven't joined yet?
Yeah, no one is joined yet.
Or if they know about let's see. Oh, so Marco can't join today.
Yes, I guess Anne on the same page. Anyway, I've just started recording. I mean, it's nonsense, but still. Or we just put it as a cancel.
Yeah, we might just have to. Well, we can. I'm not sure if Anand's going to join. Doesn't seem like
Yeah,
he is.
just wait a little
We can
bit
wait.
anyway.
Yeah, we
Yeah,
can wait a little.
definitely. Yeah.
Sure.
I just texted Anna in our chat, but I guess if he's not replying us like by maybe 10 and a quarter, um, we just finish our meeting.
Oh, sorry, I was muted. Yeah, that sounds good to me.
Yeah, I was texting him on my phone, and so it
Oh,
didn't
I didn't
tag.
tag.
Yeah, thank you for tagging.
Yeah, yeah, yeah. No worries.
Because just Okay, since they're not here, let me go quickly through the code for yesterday's, like
Sure.
labeling. I mean, at least we can give them some information. Okay, 1 second. So we have our data run through the BirdNet.
Hmm.
So and then in this case, we extracted the file name, which is right here, the file
Right.
name of the 3-second audio chunk. Dropped some redundant columns that we don't need to have. Actually, we should have dropped scientific name as well, but I guess I dropped it later on. So, and also we created buzz and call uh, as a columns with non-values to fill them out manually by listening to every single audio chunk uh, if it corresponds to Hume's Warbler sounds. And just for convenience, move the file name in front to the front, because when you um, create the column, it is appending in the end. So we just moved for visual convenience, and that's
Right.
how the our table looks like. So that just basically we got the information. We have almost 1,200 entries, observations. Then we are trying to cluster those files to see what will be the clustering result. It is kind of out of the curiosity, or probably it can be implemented on the rest of the our data, our field data. So we just using our first audio set to run the code through and see what will be the outcome. If it goes well, then we can implement it on the rest of the data. So
Okay.
basically, you creating the and actually the main idea is to as I told you yesterday, extract
Hmm.
features, right?
Right.
And I guess this code, I guess it is in my weekly report as well. So it's the you can easily look at it. So
Yeah, I did. I
basically,
did look at it yesterday. I saw.
yeah,
I was going
perfect.
through.
Okay, perfect. Yeah. So like basically, what we are doing, we extracting the features uh, like Chrome, spectral centroid, spectral bandwidth, roll-off, crossing rate, and MFCC using the LibRosa
Right.
library.
Hmm.
Yeah. Okay. And that's the first part. And the second part, we are extracting some features like embedding vector from spectrogram, Mel spectrogram. And in this case, using the TensorFlow library, and it basically gets the yeah, it's right here. So like that's what we're trying to get. We're trying
Hmm.
to get uh, mm, one, let's say like 128 embeddings, not embeddings, but the features of the Mel spectrogram. It can be 64, it can be 128, it can be 256, and the more features we are extracting, the more information we are getting. But in our case, 256 may be too heavy, as we don't have enough computational power, and 128, it is kind of a good trade-off for audio analysis. So, and the main idea is like when we extract both features using the library and from a spectrogram, we combine them, we concatenate them to describe our audio file as full as possible. Probably, not probably, some of them won't be a good use, a big help, but we're just trying to see like what features we can extract, how we can use. So basically, we are that's the file, that's yes, and that's two functions, and then we combine them in one function to make sure like when you run this function on the files, so just extracting the lab browser features and features from mail spectrograms. Yes, right. And that's like how it runs. So and actually the model, we using the simple CNN model. Just like it can be different. Like we can get 2 layers, or like 3 layers, even one layer. I'm sorry. It depends how deep you want to go, but it's very simple. And why I choose to sorry, not CNN, but SNN, sequential neural network. Why I've chosen that model and not using the pre-trained model. Actually, we could use a pre-trained BirdNet model, but somehow I didn't find the pre-trained model, because in this case, if we're doing like our own simple model, then we are not dependent on somebody else pre-trained model, which is not
Right.
the case. A lot of people can use the open source pre-trained model, like I guess like one from Google. It's trained on a lot of audio data, like all the classes like humans, like mammals, birds, just general classes, but it's just trying to create something on our own.
Right.
Which it
Right.
can, yeah.
And BirdNet's pre-trained model is not open source, right? We don't have access to that, or we have access to the, I guess, the layers that
So
they.
it should be open source, but I spent some time trying to find it, and maybe I was looking at the wrong places, but
Okay.
I didn't find it. So probably we can just maybe now um look again and see like maybe we could find it. So in our case, BirdNet model will be probably the better option. But it's not really the main point. So yes, then so we extracted all the data and exported them to CSV file, like a huge CSV file. Let me show it. I mean, give a second. I guess it was these features. Yes, okay. These features. Second. It looks like that.
Oh, I see.
Yeah, that's the file name. The file name, that's the chroma, like 12 centroid, bandwidth, roll-off. Yeah, MFCC 13, I mean 12, yeah, 13, I'm sorry. It can be more, but 13 is kind of standard. And that is the from the spectrogram, like 128. 128 features. Like, right here. So that's a lot.
Wow. Yeah. Okay.
In our case, it's more than enough. Maybe if it's not going to work well, we'll try to extract 256, and we'll see how it works, because it's actually quite simple. You just uh, put the 256 here, or 64. Yeah. So the clustering data, what we've done, we use the data set we just shown on the screen, and we run, so like we normalize not normalize the data by standard scalar. Then we run the HDB scan. Why HDB scan? Because it works quite well with noisy data, and in
Okay.
our case, it's also good because the data set we're using right now it's quite small. Probably when we're going cluster the large field data, we might use another algorithm, like a clustering in bunches, not just like every single audio chunk. But in this case, it's quite it's working. I will say okay. So like that's the just yeah. And the minimum cluster size 10. It means so like minimum we have 10 data points in the cluster. It can be like 50. It can be any other number. I just wanted to make sure like it's at least some number. But it's up to us to decide what is the minimum cluster size. So like and also like that was the optional to see like how many noisy points we got. So like when we ran the algorithm, so we found two clusters, which is okay, and 183 noisy points. So it's basically 10%. It's a little bit, yeah, a little bit more than 10% is noisy points according to the clustering mod, and then you plot the results. And in this case, what we got the cluster 0, which is red,
Hmm.
and the noisy ones. So, but the noisy ones, it is kind of outliners, like right here, like on top and the bottom, and the cluster 1. So that's what we got. And then you just I'm added the actually I've done that. Okay. Anyway, doesn't matter. So we added the labels as a clusters. Yeah, because I was actually yeah, because I've done a double work. I should write C capital as I was just renaming here. But anyway, let me see. Yeah. Okay. Doesn't matter. Let's do it right now. Yeah. So you add in the results of the model to our basic file, which was data with features. And now we have the data with features and labels. So as you can see, it's like that's this one, and then we got the another one.
Oh, I see. Okay.
So yeah, we adding up the labels. Yeah, so like and then we just because we don't need all these features definitely for our purposes, and the purpose is to manually label the data. So what we got the file name and the cluster. So the meaning is this audio file belongs to cluster 0. This audio file belongs to cluster 1, and so on. So in our case, what we are going to do, we merge in the BirdNet and cluster data frames. And the cluster data frames, this one. So just on the left, by the so like in our case, the BirdNet has the file name with the audio files, and this one is file name. So we merged and we got the data. So we got the data merged, and then we just basically as yesterday, like yeah, we merged and we just manually go and label is it bus or call, or maybe it's like no bus, no call, or bus and the call. And previously we ran the BirdNet model based on confidence level 0.1. So we can see here some species have 0.13, like 0.1 up confidence level till up to almost 1. And we are waiting for our domain expert Pranav to
Right.
double check the files
Verify
and
that.
verify. And actually, as all these files were collected um, by you, by Vanessa, right, from Xenogenta and iNaturalist. So a lot of sources, and by as we were talking a lot about the accuracy of BirdNet model, so we can define the accuracy when we got the final result from Pranov, and we
Right.
can see how accurate the uh, BirdNet is working on defining Hume's Warbler. In this case, we can put it in our papers, just explaining how it's going to be working on the rest of the field data. And this data will be used as our training data for our Hume's Warbler bus and call labels.
Right. Do we still want to set, I know Pranav is going to be labeling all of that data. Did we still want to give him blind samples?
So I gave him blind samples.
Well,
Like
okay.
when he, yeah, so I gave him blind samples. 1 second.
Oh yeah, I think I do remember you doing that. Like
Yeah,
you
so
give him like the whole file, right?
yeah. Okay. Oh, okay, gotcha. Yeah, so yes, so the samples are blind, as we can see here. They are blind. Oops. Gosh. Anyway, they are blind. Yeah, so just like the file name and the button called Pranov. That's it. But technically, he can look at this file and see like the information, which doesn't matter, like because mm, I guess he won't just look at those files.
Right. Um, okay.
Yeah. If you want to share anything like or like any questions to our computational experts, let's do it now. So like, because in that end we just put it all the questions in our transcript, and at least we can ask those questions
Yeah.
online.
Um, I don't have any off the top of my head. I guess what I'm just trying, we're kind of doing two things here where I mean, we'll have to wait for Pranav, but basically, um, we are measuring the accuracy of BirdNet, and then we're also building a model and uh, seeing if we can discern the buzz and the calls for Humes, right?
Yeah.
And unless we use, I mean, I guess my question is, how does BirdNet fit into all this if we're building our own model? Unless we find a way to use BirdNet's pre-trained model, that might be still good to have, I guess, information on like what the tools are in the world.
Yeah, definitely.
Um, no, that's really all the only question I had was kind of just around that. But we can see. I'm curious to know if we're gonna still meet with them after this week, because probably not, right?
I have
Unless
no
it's somebody
idea.
else.
I have no idea, to be honest. It's just because
Okay.
it seems like the end of semester could be a little bit of messy, and
Right.
everybody's reporting. So
Right.
I have no
Okay.
idea.
Okay.
I'm sorry.
No, that's fine.
Okay, then. So let's wrap up, and I'm gonna send the transcript and update
Okay.
the our channel.
Okay. Sounds
Okay,
good.
then. Happy Friday.
Happy Friday. Thanks, Andre.
Thank you. Bye.